All right, everyone. Let's go over 4.5. It's a graphing section, so I don't want to add too many details. You can use your graphing calculator. You can use that to get the answer. I'm not gonna spend too much time on this, but I'm gonna show you real quick how you would do it by hand. This is the first question on the homework for 4.5. So notice here they changed the amplitude, right? The original is right here, right? So they if they add 5 over 2, that's going to scale the graph. So the original has an amplitude, meaning a highest point and a lowest point of the y value, right? How high does it go up and down? Because it cycles forever, is 1 and -1. Like the big thing they want you to know is for this section, or what I want you to know, is what does each function look like? What does the sine function look like? Cosine, tangent. So just graph them and look at them. Or draw them on your formula card just so you know. But the way you do this is kind of like how we did in college algebra, how we transform the original, the parent, and then we scale it by something. So the 5 halves is going to change the amplitude, meaning it's no longer going to go to 1 and -1. It's going to go to 5 halves and -5 halves. That will become the newest high and low point. So what they do basically is you take all the x inputs and y inputs. These are all the numbers from the unit circle right here. So they say, well, let's just shift them or scale them by the 5 halves right here. So they have the original y values there. If you multiply them all by 5 halves, you're going to get these numbers. So the way you answer the question, right, you plot the new one. So instead of putting 1 and -1, you're going to have 5 halves is right there and -5 halves. That's pretty much it. Let's look at another one. So that's if the number is on the outside. So let's just do a quick rundown. Where is the question? I think it's this one. Yeah, there it is. Ouch. So let's look at the answer key so we can show you the steps. Now, this time the number is inside, so this will affect the period. Okay. So when it's on the outside, it affects the amplitude. When it's on the inside, it affects how fast it repeats. Okay. So that's the concepts that they want you to know. Just what is it? What do these pieces do? Okay. Now, what you end up doing basically is you look at the x values and you shift them. You multiply by that amplitude, 3 halves. So now this is the new x values, and that's going to be used as your input. But again, I would just punch into your graphing calculator or to Desmos and just plot your points. It's not a big deal. I don't want you to waste too much time on graphing, and you will be allowed to use your graphing calculator and or Desmos, okay? I'm gonna see if I can turn on Desmos during the test, so I'll have to see. But anyway, double check everything. Yeah, they just multiplied by 3 halves, it looks like. hmm Okay, now let's move on to transformations. So this is the general form. So they want you to know, okay, well, what are they doing to the cosine? So this is your general form for cosine, right? Remember we said that the A is the amplitude. It will determine how high and low it goes. But the D that we didn't talk about is new, shifts the graph up and down, just like we did with the parabolas back in the day. If you had x squared plus 2, it would shift the parabola up 2. Now this would be shifting the cosine up 2. Okay, so on this question, we have an amplitude of 1/2, so that means that the original is right here. It's going to be shrunken down to 1/2 and -1/2. So that's the first thing. So all the original values will be shifted, or right, all the y values will be moved, will be changed by 1/2. Now, if we now account for the 3/2, that'll shift all the y values. So in other words, it's going to move this graph up by that amount. The first thing you do is remember what the original looks like. Again, this is if you do it on paper, right? You graph the original, then you change the y values because of the amplitude. And once you have that, you move it up by whatever's on the outside. We have 3/2 on the outside right here. See, the instructions are move it upward by 3/2 units. This 1/2 is what shrank it down here. And then that's it. So just like two steps here. And then you'll have your graph shifted up 2, but also shrunken down by half because the amplitude is 1/2. So vertical shrink, then vertical shift. So that's what the D does, and that's what the A does. Okay, so you would just graph that. And then you can or you can use your graphing machine. Okay, let's move on to something else here. These are more interesting, I think. This is the type of question that I would like to ask, but you need your formulas. Okay, so first thing, what is the amplitude? Well, that's the easy one. It's right there in front of us. Then they ask for the period. That's going to be a formula. Let me see if it's on here. If not, I'll have to write it down. Yeah, here it is. Right here. This is the formula you're going to use to find the period. The only thing is you have to first factor it to put it in this form. Then you have the B. You can't just straight up do it. You have to first factor. So let's look at this guy here. Notice how they have there's a pi in common inside. So you factor the pi first. No matter what, you factor whatever is on the x. So basically we're forcing a factor. So let me write this out. You have a 2 pi x plus pi. Now if I factor 2 pi x, notice how this doesn't have a 2 in common, but I'm going to force it. You can do this. We don't usually do this, but we have to for this type. So this loses the x. All right, if I factor pi out of both, they're no longer going to have pi. If I factor 2 from both, the first one will lose the 2 pi, right? So 2 pi is being factored out of the first one. But this guy right here is going to become, let me think. If I factor 2 pi out of both, it's going to be 1 over 2. Yeah, there we go. Because I multiply this back in, the 2's will cancel, getting me back to this, right? So if since it didn't have a 2 to begin with, if I factor 2 out of it, it becomes a half. So 2 pi, remember, oops, Just in case you're like, what is that? How the hell that happen? Or what's going on? You multiply it back in, right? Let's do it over here because I'm gonna undo what I did. That becomes 2 pi x plus, right? 2 pi times the 1/2. So see how the halves are gonna cancel? So now I'm back to here where I started. I just want you to see that this is all the same. So if I'm gonna factor a 2 pi out of this, right? Out of this guy, it's gonna turn into this. Now, once I have it, then I know what the uh, B is. In this case, B. So period, the period will be, meaning, and again, period is just how often it's repeating itself. Okay. Period is going to be, where is it? 2 pi over B. But in this case, the B is that 2 pi, so they're going to cancel completely, which is kind of interesting. So period is actually just 1. So period is 1. Amplitude is a half. Phase shift is going to be, I think it's the C over B. Let me see. Yeah, here it is, C over B. I'll call it PS just because I don't want to write all that. Is C over B, which will be uh, right there, 1 over 2. But it's going to be opposite signs because check them out. It's negative. So I think we should build it in. Well, hold on. Yeah, here are the formulas. That's prettier. So in our case, yeah, it will be negative. Hmm. So it will always be the opposite of what this is. So our C, strange, is negative pi over 2 pi, which is the B. So it should be negative half. Hmm. Let's go look at the answers. Yeah. Amplitude is half, phase shift is negative half, period is 1. So yeah, we're all good right there. So I prefer these types of questions because we're not graphing anything, we're just getting information. So using the formulas, amplitude is always the A in front of the function. Period is always going to be 2 pi over B, but B, if it's not in this form, right, if there's a bunch of numbers on this stuff where there's a plus, then you have to factor first. And then once that's done, you can get the phase shift right away. All right, let's go to another one. So there's formulas for, make sure you write down the sine and cosine are going to be the same for amplitude, period, etc. Just write those down right here, this guy. Yeah, it's going to be the same for both. This next one is pretty conceptual. It kind of wants you to see what is the amplitude? What is whatever? Let me see if it's worth doing. One moment. Okay. So on this question, they basically just give us the graph and they want us to build the equation. So we're kind of going backwards. So this one's a little harder because you can't just graph it in the machine, right? It's like, well, you got a picture. Now, the first thing you need to do is identify, is it sine or cosine? So you got to go back to unit circle, or you have to know what the graphs look like. Again, that's why I said you got to learn what they look like, the originals. And we should know, if I mean, you will know eventually that, oh, it's right here, check it out. Sine starts at zero, and cosine starts at one at zero. Because if you plug in zero on the unit circle, cosine is one. So notice here, it's starting at the peak instead of starting at zero. So that's a big hint that this is cosine. So that's the first step. Like, okay, is it sine or cosine? So we rule out sine. It's going to be this guy because it's starting from the top, going down. Now, if it was starting from the bottom and going up, it'd be a negative cosine. Okay. Now the next thing is check, well, how high did, if it is cosine and it's starting there and it's not negative, how high did it go and how low did it go? You can see that it's 5 and negative 5. So that's a sign that, yeah, the amplitude is going to be 5. So we know it's going to be 5 cosine. That's an ugly 5. It's like an S. Cosine of bx. So now I need to solve the b. Right? And it's not negative 5 because it's not flipped over. So positive 5. Right? A is positive. A is the amplitude determined by the height and, you know, how high to go and how low to go. Okay. And then we need to solve for b. Like, well, I need to figure out the period. So yeah, look at the graph and say, okay, well, when did it repeat? It started here, did some stuff, and then it started over and started over again. So what is this distance from here to here? That's 0 to 4. So that's 4. So the period is equal to 4. So basically you say, okay, well, that means that 4 is equal to the 2 pi over b. So you set it equal to the formula because we know the period by looking at it, but we don't know what the b is. So you do your algebra, solve for b. That's what we're gonna do. That's what they're gonna do right here. So here's the explanation that we had just mentioned. Find the amplitude by seeing how high and low it goes. That gives me the a. You choose positive 5 because it's not starting at the bottom, it's starting at the top. And it's rehashing the same thing. Then we find the period, which happens to be 4, right? Because that's the distance from here to here, which we just did. Scroll down. This is the algebra part I was talking about. You set 4 equal to 2 power b, which is the period formula, right? Multiply, you can do, we can flip both sides over. You can do whatever algebra you want to do. Multiply both sides by b, divide by 2 pi, do whatever technique solves for b. Okay. They were a little more fancy than I would have been. So they kind of just went straight there. They probably did more of a, they skipped a few steps here. What I would have done is multiply both sides by b on this line. I would have got to here, right? Because if you multiply both sides by b, that b cancels on the bottom. Then I would divide both sides by 4, which would give me to here. And then this reduces. So then that's when we get the pi over 2. So once you have all the pieces, you have that a is 5. You have that b is pi over 2. You just plug them into the formula, or these, it's kind of like a standard form. Y is equal to, right, a cosine bx, which will be equal to 5 cosine pi over 2x, and that's it. Just plug it all in. That's why they got this. So using the picture, we get information, and then we plug in that information to this formula here. Okay, and you have to know which formula to use based on what the graph looks like. So if you're not sure when you look at it, graph the original sine cosine and then choose the one that looks like it. And then see if it's a mirror, right? If it's flipped upside down, there's a negative in front. Just like the parabola back in the day. If it's pointing up, it's positive, and if it's pointing down, then it's a negative. But yeah, that's pretty much it. There's not, again, like I said, I'm not gonna grill you on the graphs. Uh, Let me show you the homework again. So we're just going through the homework and looking at the explanations. The first few are just understanding what the originals look like and what the signs do to the graphs, how they flip over. And then sketching the if with different amplitudes and different numbers in front, then you might have to factor. See how there's an x plus c. That's when we pulled out that b and forced it to change. But these are all just transformations of the original. So if you have the original sine and cosine and you make them look different by changing the a's and b's and c's. 14 was the one we had to find the amplitude and stuff. So that's when we did it together. And then 15 was the one we just did. 16 is similar, but it's just maybe a little harder or just different. But anyway, again, all these can be solved. About 90% of these can be solved with your graphing calculator or Desmos. So I don't want to spend too much time on this. Just what I want you to remember is what do the trig functions look like if you were to graph them? What are the amplitude? How do you find amplitude, period, and phase shift? And can you pull that information off the graph or the equation itself? That's what we did. Alrighty. Anyway, that's pretty much it.